Hello everyone and welcome to this presentation. Today I'm excited to share the results of our work on auditory display for social interaction in extended reality developed by the multimedia technology team at EURECAT. Our focus is on addressing audio-related challenges in virtual environments to improve the way we communicate and interact. Effective social interaction heavily depends on the ability to communicate with each other. The main communication channel for humans is speech, which of course is an acoustic signal that we perceive through our ears. When acoustics are poor, communication suffers and interactions become challenging. For example, think about how frustrating it is when audio issues disrupt a Zoom call. It's hard to connect and collaborate. Poor audio quality can have an impact on our conversation in a Zoom call, in virtual environments, and even in real life. For people with hearing difficulties, the issue of poor audio quality is already a significant barrier. Now, with the new technologies like extended reality, we have incredible opportunities to explore solutions for rehabilitation and accessibility. However, the challenge lies in making these experiences inclusive for everyone, ensuring that people with hearing impairments can fully participate and benefit from these advancements. However, in virtual meetings, audio quality is often far from ideal. Participants connect from different remote locations, each situated in a unique acoustic environment with varying level of noise and reverberation captured by their microphones. This creates two key challenges. First, noise from diverse environments, and second, mismatched room acoustics. To address these issues, we focus on two technical solutions: speech enhancement, which improves speech clarity in noisy settings, and acoustic matching, which ensures that all audio signals sound as if they originate from the same acoustic space. In the following slides, I will present the results of our work addressing these challenges. The first result I want to share is about improving speech enhancement in hearing aids. Hearing aids often have a hard time reducing noise in complex environments. By using new deep learning-based methods, we saw the potential to make noise reduction much better. To do this, we created virtual acoustic simulations to generate the data we needed for training and for evaluation. We then trained the state-of-the-art deep learning models and compared them to traditional methods. The deep learning models did a much better job at reducing noise, but they also introduced some distortions that affected the sound quality. So there's still more work to be done to balance these trade-offs. The second result is also related to speech enhancement. In this study, we used virtual acoustic simulations to generate a novel and better audio dataset, which takes into account details like source and receiver directivity characteristics and acoustic propagation in rooms. We trained a state-of-the-art speech enhancement model with this new dataset, and we found that it improved the model's performance. Let's listen to some audio examples. Traditional denoising methods work well in stationary noises, but they struggle with denoising more unpredictable, abrupt sounds or sounds that are more similar to the speech itself. So let's start with removing intense noise. This is the sound before denoising it with a network.
Has so undergone the process.
And this is the sound after the processing.
Has so undergone the process.
And another example before.
What made the quarter all the greater is the
And after.
What made the quarter all the greater is the
Now let's see how the algorithm deals with abrupt background sounds. Here's an example before the denoising.
Seated in a little wagon on her way.
And after denoising.
Seated in a little wagon on her way.
And finally, let's check how this deep learning model removes more melodic sounds. Example number 1.
Such accident, it is but
And example number 2. The shareholders will vote. The shareholders will vote. I hope you can agree with me that deep learning model and in general deep neural networks are great at enhancing speech and can deal with variety of different noises. The third result is related to acoustic matching. In augmented reality, the sound of our virtual conversation partner must be seamlessly integrated into our own soundscape. We developed a deep learning method to make speech recorded in one space sound like it came from another space. This approach performed better than traditional signal processing methods, but more work is still needed to reduce distortions and to develop specific acoustic evaluation metrics. Here I want to share with you some audio signals generated with our approach. Our method takes two arbitrary audio signals and adapts the acoustics of the first signal based on the second one. First, let's look at the example where our model transforms the sound from the larger reverberant space, like this empty white room on the left, to a smaller space with less reflections, like this cozy bedroom on the right. So first, let's hear the sound recorded in the big room.
There's nothing I can say.
And now let's hear another sound that could be recorded in a small room.
They were raised in the European Court of Human Rights.
Now our approach uses these two signals to change the properties of the first sound, the content sound. So here, let's hear how it sounds.
There's nothing I can say.
And finally, we can compare the processed signal to the ideal signal from the cozy bedroom. We call it a target because this is what we would like to achieve with our method. This is how it sounds.
There's nothing I can say.
So, to wrap up, we went from this.
There's nothing I can say.
To this.
There's nothing I can say.
And the ideal signal is this.
There's nothing I can say.
Now let's look at another example where the transformation goes the other way around. So now we go from the smaller room to the larger room. So the method has to add reverberation, not remove it as in the previous example. First, let's hear the sound recorded in a smaller room.
We have to look at everything before we...
Now let's hear another sound recorded in the larger room.
I was shaking on the blocks.
And now we will hear the sound generated with our method.
We have to look at everything before we...
And we can again compare it to the ideal case.
We have to look at everything before we...
So again, we went from this content sound.
We have to look at everything before we...
To this prediction.
We have to look at everything before we...
And this is the ideal case.
We have to look at everything before we...
That's all acoustic matching samples I can share with you today. And now let's go back to our results. The final result I want to share is about integrating and testing audio technologies in virtual reality. We created a virtual sound environment that simulates a typical VR remote meeting. We conducted a pilot user study to validate our virtual acoustic scene and to assess the impact of various speech enhancement techniques on communication. Participants were seated in a virtual room with 4 avatars and listened to their conversation. During that time, they could switch between different audio processing techniques. After this virtual reality experience, the participants responded to a questionnaire. Let me demonstrate a fragment of this interactive environment to you.
Actually, where's everyone from? I'm originally from India, and I moved to States in 2012. For about a year, I was. That's what you say. That's happened. That's how exactly. And then for the first year, I was in a lot of states. It was kind of fun to see different states and stay there. But I think I'm here in the Bay Area since 2014.
Where were you at before the Bay Area?
I was coming from Cleveland, Ohio.
Oh, it's
You
interesting.
brought James Town.
Yeah, there you go.
Relevant.
How about you guys?
So I was born in India, but I've lived in 10 cities till high school. So I moved around a lot in India. Then I lived in Indonesia, and then Bangladesh, and then I got here for my graduate school. So it's been 3 years in the US now. Yeah.
Cool.
Yeah.
You said you're from Chicago area?
So yeah.
The result of this study, conducted in this virtual environment, showed that only some speech enhancement methods actually improve communication. This study highlighted the potential of using virtual reality as a tool to study speech communication, and we plan to continue exploring this area in future research. With this, I have shared the key outcomes of our work on auditory displays in the Guest XR project. Thank you very much for your attention and feel free to reach out if you have any questions or feedback.